Okay, so I'm just going to go over the sort of different ways that you can use async in JavaScript with a brief explanation of what it is to start. So on a side note, it is differently handled to the way things like .NET handle it. There's a few different rules which make some things easier and some things probably a little bit more complicated. If you want to go through that, we can do it in another session, or we can do .NET in another session, I guess. So one important thing to remember, or one important difference, is that JavaScript is single-threaded. So this can cause you some problems if you're not writing asynchronous code. So if we just look at a little example I've got here. So this is just an Express API. I'm basically got a get method that is just going to log out a count of the number of times it's been called while incrementing it, return the word test back. And I've got another method that is going to use one of these synchronous file loading helpers that's given by Node. So we're just going to load this file that I've tried to make relatively big. So if I just fire this up. So that's just got the API started. And I've got another little helper that's just going to continually poll that. So seeing here that it's just continually polling it and going up. Now, if I go to my browser and I hit that data endpoint, what you notice is the other endpoint freezes. Because of the single-threaded nature, it means if one thing is going on synchronously, your whole application will stop while that runs. This is really important to remember because Node's sort of async pattern does make it quite good at handling lots of requests, but if you put any synchronous stuff in it, it is going to bomb out the entire server. So yeah, every time I'm hitting that, you see it just causes freezes on the other endpoint. So all those requests are sort of like bunching up and then coming through together when it's done. So how do we handle that asynchronously? So what we're going to be doing is basically passing around other functions and saying, when I'm finished doing this long running thing, so file read, HTTP calls, database reads, they're all sort of main things that are going to take some time. I want you to then execute this other function. So little example before we get to proper callbacks. Let's say I want to just log something out when the application started. So you'd think, okay, application has started. So it goes in here. And this is interesting because it'll sort of look like, okay, that's done properly. But this actually accepts a callback for when it has completed. So if I then pass a function into here, in there, I can put application has actually started. And what we'll see there is the file is going to finish, so this will execute, but it hasn't actually started at that point. When it started, it calls the proper callback method. Just one to be very aware of if you're seeing sort of strange order of execution, you probably haven't realized you're calling an asynchronous method. Cool. So this is actually called a callback function. Callback functions are executed upon completion of some slow running task. So let's go in here and start having a look. Let's clean this out a little bit. So for example, I want to read a file and then do something with the contents of the file. All the default long-running things like FS to read files accept callbacks. So I'm just going to set up FS, read a file. I've just got my file path. Just going to say the format that I'm expecting the file to be in. And then the last argument is the callback. I think callbacks by standard are always the last argument. This is definitely the way all the Node packages work. You might find some third-party packages that work slightly differently. And then coming into that callback, the first argument will always be the error, and we normally just call that and then we get our data in this case, or whatever data is being passed back to us. So we should be able to basically say, if there's an error, I guess we'll just throw the error. Else the data is good, so it's console.log. Data. Should just be able to execute that file. So see, it's reading the data out there, and that's getting executed in the callback. I guess if we break that, we should see the error handling in action. So essentially, if something went wrong, it just passes an error back. It's another thing to be aware with, like, the sort of throwing exceptions up. Generally, that's not done with callbacks. The callbacks, everything passes the error back up as the first argument. So let's say I was trying to write my own function that takes a callback. So I might be doing something like HTTP request. So I'm just defining a function to do a HTTP request. Internally, it's just going to use another function with a callback, but that's going to take a URL in and a callback in that I'm going to execute upon completion. So then I'm going to use the request package to do that. That is going to basically just, I'm going to call the URL, and this takes a callback as well. Same thing, get the error through. And then really all I'm going to do is, if I want to do add some additional processing in here, I can say HTTP done. And then I'm going to execute the callback that was passed in. I'm going to pass the error back out in case there was an error. So the top level can handle the error. And then where I'm executing that, I'm going to just say, call that, and then I'll define my callback that handles, and I'll say callback. So let's just run that, check it works. Cool. Oh, let's just get rid of that. So what we're seeing there is we execute this function, which comes in here. Execute, that calls out to another function with the URL. When that's completed, this callback fires off, and then calling, basically logging out HTTP done. Then we're going to call back to our top level callback, which is going to output callback. So this sort of relatively simplistic way of doing it, the default way in Node, you'll see it used in some places in JavaScript as well, if you're not in sort of big frameworks. Starts to break down when we do things like, okay, actually, when I've done this request, what I actually want to do is do another request. So I'll say, okay, then I'm going to do Bing, and into that. So I'm already starting to get collisions on my error names, which might not be a problem if each callback is handling it internally. And they say, okay, actually, I'm going to get another piece of data. Ask. And then I'm going to do it again. And you start getting into what's called callback hell, which is essentially I'm going out and my code, sort of to understand the way it's going through, is moving more and more over to the right-hand side of the screen. You imagine if you're doing anything that's non-trivial, this can start becoming very nested very quickly. And you can go, okay, I'll start breaking out. I'll only have 3 levels of nesting in each function. Then that kind of helps it a little bit, but not the best solution. The other problem, this is all going to execute one after another. So I'm going to execute those synchronously. What I might want to do is execute them all at the same time. So if we take an example of that and say, okay, I'm just going to create a method load 2 at a time. So within that, what I really want to do is trigger the first and second one at the same time. So they'll trigger at the same time if I do this, or shortly after one another. So I'm basically going to start both of them, and then wait through both of the callbacks. But I'm then trying to sort of wait for the last one to happen, and then I want to put my call my callback. So it all starts getting very sort of low levelly at this point. Okay, let's just have an integer called done, and then every time one finishes, we'll increment done, and then I guess we could say, yeah, if done equals 2, do the callback, and then it's like, okay, well, what if I want to join those pieces of data together? Like if I want to get the data that comes out of both of those, I start passing it up into this scope and then checking it and passing it. It becomes very messy to manage. You can create little helper functions to do this that maybe take an array of methods that have callbacks. It starts becoming pretty ugly pretty fast. So that's where promises come in. They're trying to solve these problems. Let's make sure I've gone to it. Yeah. Okay. So we're then looking at promises. Now, a promise is an object very similar to like a task in .NET, doing the same job. I'm going to start it off, it's going to do something for me, and then when it's done, it's going to let me know. Similar sort of thing to callback. So how do I create a promise? So let's say I have a HTTP function again. Actually, we'll just go with the load function. So this is going to be to read a file. So this is going to be the location of the file. And then what we're going to do is we're going to return a new promise. Now, a promise takes a function quite similar to a callback that has resolve and reject on it. So within that, we're then going to do our file loading. So I'm going to say read a file from that location. Again, I'm just going to pass my format in, and then this takes a callback. So what we're going to try and do here is wrap the callback with a promise, so we don't get all the problems associated with callbacks. So basically, if I get an error, I'm going to want to call this reject method on it, and that's going to tell the promise that it's failed. So in this case, we just say if there is an error, return reject error. Just one side note here, that the return has nothing to do with what the promise is doing. That's to do with the call here. We're only returning here to stop it falling through into this part of the code. So we're basically pretty easy to actually, for just case of simplicity, to just write that to make sure you see the difference. So we're not actually returning anything. We're just making sure that we don't reject and then resolve. And then resolve, and that will take the data in. So the way I call this, I say load, tell it the location of my file. Then what you get with a promise is a .then method, and that will get basically whatever's resolved out of this will come into here. So in here, I can just say console log loaded. Just see if that works. Okay, so that's then loading through, and we're seeing the console log saying we loaded the data. So important notes here, a promise doesn't need a .then to execute. It will start the moment this promise is newed up, it starts executing. So if you don't have a then, it'll just execute and just do nothing when it's finished. So then what we're going to do is, let's say then we want to do another asynchronous operation. So we're going to then do a, let's just wrap that up as well. So there's another way that you can simplify wrapping a callback into a promise. That's a lot easier for this. I've just sort of done this to give you an example of how promises work if you do need to define them. There's a util method called promisify, and this will take any standard looking function, so where the callback is the last parameter and the first parameter of the callback is an error, and it will convert it out into a promise. So I can say, can you please turn request.get into a promise, and I can just call that HTTP. So let's say then I want to do a HTTP call to Google. I'll say HTTP, I'm going to pass in my urls.google, and then after that's done, I'm going to get my Google data. Let's say console.log request done. So we loaded the file and then we did the HTTP request. You can see this is already starting to move over to the right again. If I wanted to do another async action afterwards, I would be coming in here and moving over and over. So this is where one of the important differences of promises is. They bubble out. So in a then block, if you return another promise, it will go into that then chain. So it's probably easier to show you. So if I return that promise there, I can move that then down to here. And this is basically how they start getting around the callback hell. So that should work exactly the same. They were basically going to come into this block. Basically, that will fire up this promise. When that promise is done, it's going to come into this top level then again. So that works exactly the same. Now, error handling in promises is, notice there's no errors getting passed around. It's just done with a .catch. So you can basically say, if there's any error, catch it. This is really powerful because instead of in callbacks where every level we're having to pass those errors around, which we might want to do, we might want to handle them locally at least. If we don't actually need to, we don't care. So while as long as the promises are bubbling out, if this has an error, then the error is going to come here. So it doesn't matter where the promise is in the chain, as long as that the then would come through there, the catch will come through on the end as well. A couple of little side notes with this. If you throw anywhere in a then or in a then chain, it should come out the catch as well. So that's coming out there. So we're executing our first block, then getting the error. Be careful not to throw inside of a promise definition like this. I'm pretty sure that will not, you need to reject in those cases. That's why it's better to just get into like a then chain situation with the majority of your code rather than having lots of promise returns. Because anytime you're using a promise, if I was trying to create a function that used a promise, I can just put a then chain in it and return it out. So if I was to do load data, if this was using the load function inside it, I was saying load file, then so this is just giving me some data. Maybe I want to do another async operation, or in this case, let's say actually I just want to pass the data. As long as I make sure that I return that chain out, after that is executed, that returns a new promise that's passed out. So it then actually returns another promise. So when that's completed, that will come out and I can add another then on it. So I can just say load data. And that should get my object as well. So you will see as well, it's definitely meant to do this on purpose. If you don't have a catch, you will get this unhandled promise rejection come out. So generally at the top level, it's also always worth having a catch, just because this will obscure the errors that you're actually seeing a lot of the time. Yeah, so we're seeing now that's coming out. I can go back to my little bug one and see that the error handling works as well. Another interesting side note is that if I do have an error in here and I catch it, So let's not log that out there. So I catch it there. This is not going to trigger the outer catch block. If you catch an error, it still returns a promise, but it returns a resolved promise. So potentially what I could do, I'm pretty sure this works, is if I caught an error there, I could return some default data. And that should switch out my object. Yeah, so because I've got an error in here where it's failing to pass, this is catching it and then returning a happy or resolved promise back out. So we don't actually trigger. If you do want to sort of catch at multiple levels to add additional data to your exceptions, you just need to make sure you throw inside of the catch block or return another rejected promise. So there are some little helper methods where you can say, actually, I just want to return promise, reject, and pass some data in there. Then that'll trigger out into the error handler. So that's triggering into this outer error here. You can pass the data through that way, I think. Yeah, this is the outer error. Also, same sort of thing will happen if you do throw new error, which you might want to do just because that's going to include the call stack information on it as well if you wrap it in a new error. Cool. So that's pretty much the basics of promises. Now, we then sort of move into async await, which looks a lot like what you're used to seeing in the .NET world. The code looks a lot more synchronous. It probably is in some ways easier to comprehend. The one thing to note on this is that Node at a top level does not allow you to create or execute async functions. So there's a couple of ways to get around this. So basically, I can't define an async. I can't use await at this sort of root script level. So I can't just write await and something in here. It's not going to work. I need to at least wrap it in one asynchronous function for it to work. So you can either basically define an async function like that, and then don't await it, but execute it like a promise. So essentially, anytime you're creating an async function, you're actually just creating a promise. It's just a way of hiding the fact you're creating a promise. So for example, in here, if I do that, you see this works exactly the same as a promise. So any async function can be used like a promise, but essentially what we're doing is we're building on top of the promises with a nicer syntax. So you can't await anything there, but inside of these functions, you'll be able to use await. One side note on this is if you want to save yourself a lot of time and you're using file system functions, is just to install the FS Extra package. It basically meets the same interface as FS with some additional methods for commonly done things, and also will, as well as accepting callbacks, will also automatically return a promise for every method. It just saves you having to util promisify everything. So within my async function, I'm basically going to just say, let's load some data. So I'm going to load my string, and I can then just say await fs.readFile, the file path, and 8. So that's just the file type, and let's just log that out. I need to execute function. So that's executing through. So basically all await's doing in this case is unwrapping the promise for us. So if I remove that out and run it again, you can see, oh, I actually need to log what it is. You can see in there that this is a promise. And when I put the await keyword in, instead of the promise, what we're going to do is the code's going to pause here and basically act as if it's waiting for a then before continuing down. So instead of sort of chaining our thens now, if I then wanted to do a HTTP request, let me just grab my just getting my wrapped promise for request. So if I then wanted to do a HTTP request, I can do const returns the body await HTTP urls.google. That should go through as well. The only other thing, oh, sorry, error handling, yeah. So error handling in async await then is going to use the sort of synchronous default way of error handling. So instead of having catch blocks around, what I'm going to use is try catch. So basically, if you put a try catch block in here, if any of these promises return rejected promises, they're going to go into this error handling block. So it just feels a lot more like writing synchronous code. You just have to make sure to define your functions as async so that it creates promises when it puts them out, and await so that it unwraps the promises for you. Let's just do a little error thing here. So if I change this to an invalid file, I should get unhandle promise rejection. Maybe that doesn't trigger the error handler. I might have to look into that one. Yeah, I'm pretty sure you should be using try and catch with async. The other thing is that both of these solvers is they just give you some helper methods as far as how do I execute multiple things at the same time. So this is the same whether you're using promises or promises and async await. Say I want to execute two promises at the same time. It just gives me a helper function called promise.all. This is going to take an array of promises and return a single, basically return a single promise with an array of answers. So if I were to do, so I'd say fs read file in there, and also I'm just going to do HTTP.
Go for a little.
So that's going to return a single promise, and that promise will resolve when the other two promises are done.
Yeah.
So I can then get my data in here, and this first one will include my file data, and the second one will be my HTTP data.
Yeah, cool.
Ash, sorry, your mic's muted, just so you know.
Sorry, guys.
So that will basically then resolve with a single array where both are complete that has the data in. So let's do console.log. Data, console.log, file. Let's try that. Yeah. Apparently Google has a lot of data. Same again. If you want to use async await with that, you can just change it to a async function, and you can just await that, and you just say const, and basically just get your data out of there. With promise.all, it's always good to use the array deconstruction as well. So the promises won't come out in the order they execute in, they'll just be the order they're passed in. So you know, as long as the first one I passed in is read file, that's going to be the data that comes out of it. And then I just need to make sure I await that to unwrap the promise. I think that's everything. I'd like to touch on the try catch stuff a bit more, but I think we're out of time. Cool. Any questions?